Today we're going to look at section 1-1, functions. And for the most part, today's lesson is pretty simple until you get to the very last problem. But the more of those that you do, the better that you get at them. So let's look at some just basic definitions. So a function is just a relationship where x values are only used once. So remember, a relation is any set of ordered pairs, but for a relation to be a function, essentially the x values cannot repeat. So if I were you, I would put here x values do not repeat. Then the x values you're supposed to know is domain. So I would highlight that. And those are the numbers that you put into the formula. They are your input values. And then of course your range is going to be your y values, and they are your output. So you have input, domain, output is range. So we're going to look at testing a function. This says there are 4 ways, but that means there are 4 ways to represent a function. And I'm just going to abbreviate function right there. So you can either have a function as a list of ordered pairs, as a graph, as an equation, or in function notation. So those are 4 different ways to represent your function. To test each one of these 4 different ways, you either are going to use do the x values repeat, the vertical line test, or if you're looking at just an equation, we can talk about that as well. So let's start here. If you have just a list of ordered pairs, all you care about are these x values. And I'm going to move, whoops. So I care about this, this, and this. Because 4, 7, and 3 do not repeat, this is indeed a function. So yes, this is a function. Then when you look at a graph, you want to apply the vertical line test. So I'm going to get my special pointer here. So my pointer looks like a vertical line. It's a lightsaber, but here we go. So if I run this vertical line anywhere through this graph, do you see how it only touches it once in any place? Never does this vertical line touch the graph in 2 places at the same time. So this first graph here is a function, but this second graph here, it's touching the graph in 2 different places. Now here it's only touching the graph in 1 place at the vertex, but everywhere else it's 2 places. So I'm going to just put through here a little vertical line and showing that here and here are the 2 places that that vertical line is touching. So for this particular one, no, this one is not a function, but we said that yes, this one was a function because when you ran that vertical line through it, no matter where you land it, it only touches that graph once. So those are some ones that you should be very familiar with. You also learned in Algebra 1 to look at an equation. Oh, let me switch my pointer out. Okay, so when we're looking at an equation, all you're going to do is look at your y value. You cannot have any powers on your range, which is your y value. So long as your y is to the first power, you're fine. But here, as long as y is squared, you're going to end up in a situation like this one is here, where it's not going to pass that vertical line test. So when y is to the first power, you're good. And so here, yes, because we're looking at y. But on the second one, because of the y squared, it's a definite no. That's an O, hard to tell. Then the 4th way is when you're looking at function notation. So usually it'll be f of x is equal to something. So if all I see is y is equal to 7x plus 2, that may or may not be a function. This happens to be a linear function, so this one actually is a yes. But as soon as they put, they meaning whoever wrote the problem, as soon as somebody writes the problem as f of x equals something, then that's in proper function notation, and if the relation is not a function, we don't write it in function notation. So those are your 4 ways to represent a function. Let's review evaluating a function. So I'm going to make this bigger and move it up a little bit. So basically, when you evaluate a function, you're going to plug in different domain values to get a range, and they're going to tell you what to plug in. So as you can see here, this is our g function, and we can keep changing what the g function is called. As you'll see to the right, we call it something different, but right now this particular function is just noted as the g function, and in place of x, we're going to put in a 2. So that happens to be our input value is a 2. So wherever I see an x value, here and here, I'm going to input a 2 in that place. So I have 2 x values in my g function. So I am going to substitute in twice. So I've got big parentheses plus 4 times big parentheses minus 3. Your substitution parentheses are very important. And so I'm going to plug in a 2 here and a 2 here. And then from there, I'm just going to follow order of operations. So I'm going to square the 2, so I get 4. And then 4 times 2 is 8 minus the 3. From left to right, 4 plus 8 right here is 12 minus the 3. And then 12 minus 3 finally is 9. So typically how you should write your answer is g of 2 is equal to 9. So now what I want you to do is this problem over here on your, well, I'm not going to let you do this one on your own because it's a harder one. You are plugging in to every m because it's g of m, so every m we're replacing the m with an x plus 2. There are 2 m's here, and so remember our substitution parentheses are going just around the variable itself. So as I write out the g function, I'm going to write big substitution parentheses. And the only thing that really changed on this particular problem wasn't the function itself, but instead of having an x, we have an m. Not trying to confuse you or anything. And so instead of m, I'm going to put an x plus 2 in for every m that's in that function. You have to be really, really careful right here because x plus 2 squared is not x squared plus 4. You have to actually write out x plus 2 times itself. So this means x plus 2 times x plus 2, and then we have plus 4 times that x plus 2, and then minus 3. And so I'm going to end up distributing, so I've got x times x, which is x squared, and x times 2, which is 2x. Then I am going to change my color. Oh, that is not at all what I wanted to do. Oh, that's just a new feature I had no idea I was able to do. I'm going to back that up. I pressed the wrong button, in case you're wondering. Let's try that again. That was a great big squiggle. All right, so again, I've got x plus 2, x plus 2, 4 times x plus 2 minus 3. I'll try not to touch that button again. So I'm distributing this. I get x squared plus 2x. I was really trying to change my color so I didn't have a red, but we'll go with it. So then 2 times x is 2x. I'm going to line up with that one. And 2 times 2 is 4. And then I am going to distribute this 4 into parentheses. So I get plus 4 times x is 4x. 4 times 2 is 8, and then minus our 3. And so now I need to start to collect like terms. I like to start with my highest degree and then go lower. So I have an x squared, nothing else is an x squared. So I've got x squared. Then for my x terms, I've got 2x, and 2x is 4x, plus 4x is 8x. So positive 8x. And then I have 4 plus 8 is 12. 12 minus 3 is 9. So I have a positive 9. So my g of x plus 2 is equal to x squared plus 8x plus 9. All right, so in this section, we're going to evaluate, but this time we have what's called a piecewise function. I'm going to make it just a little smaller. So on a piecewise function, you'll notice it looks a little different. We've got f of x is equal to two different functions, but f of x is only equal to x squared plus 1 if and only if the x value that you're putting in here is less than 0. If the x value that you're evaluating or plugging into the function is greater than or equal to 0, you're going to use x minus 1. So these right here determine where you're going to plug a number in. So any number that's less than 0, so like -2, -10, -100, those are all less than 0, you're going to plug them into this function here. But if I chose +2, +10, +100, they're all greater than or equal to 0, you're going to plug those values in here to evaluate that function. So you would, this is considered a domain that's restricted specifically based upon what this is saying here. Sometimes it'll say x is less than 2, so you have to be really careful at what this range or this domain, I guess, that they're giving it to you says. So focus on that. That tells you what path to choose here. So for instance, in this first part, we're going to find f of 2 and f of -1. So let's just start with f of 2. And I am going to highlight this in yellow. So because my f of 2 fits in right here, it's greater than 0, I'm plugging in f of 2 into this function here. So I'm going to highlight this all right here because my f of 2 matches x minus 1 because it's greater than or equal to 0. So that's the one I'm going to use. So I have f, oh, I am still on this one, so let's go back to here. Okay, so f of 2 is going to equal, I'm going to use the x minus 1, so here's x minus 1. And so instead of x, we're putting in a 2, and I end up with 1. So my f of 2 is equal to 1. And so I'm going to put a box around that. Now, when I do f of -1, so I'm going to highlight that in pink, -1 is less than or equal to 0, so we're using this part of the function. So f of -1, so wherever there's an x, I'm putting big substitution parentheses plus 1 because I have x squared plus 1, so this is my x squared plus 1. We're going to plug that -1 right into there. So -1 goes in here, and I'm going to separate my work for these. And I have -1 squared is 1 plus 1, which is 2. So f of -1 is 2. All right, so something I want to point out to you, so I'm going to move this over here so I can highlight it, but I wanted you to note that you have to focus on the numbers and where they substitute into the function. So those numbers you can substitute in the function, it just depends on what it matches when it comes to this. All right, so let's look at something that is not restricted. So if you look at this particular equation right here, there's no fraction, there's no radical, there's no, well, we'll talk about real life problems in a minute, but there's nothing here that would restrict the domain. So you can plug in any real number you want to, positive, negative, 0, fraction, decimal, it doesn't matter. It's not restricted. But restricted ones, I'd like to focus on that for just a little bit. Restricted ones are the following. If you have a fraction, you would look at the domain. Your domain cannot equal 0. So x minus 4 would not be able to be 0. So we have to figure out what value x would be to cause a 0 in that domain. So solve this equation for x, and you would add 4 to both sides. So as long as x is not 4, you can plug anything you want to into this function. But as soon as x is 4, 4 minus 4 is 0, and that fraction becomes undefined. Square roots are the other culprit. So anytime you have a square root or really an even root, you cannot take an even root of an odd number. So this number underneath the even root must be greater than or equal to 0. So we're going to take this value. I'm going to highlight this x value here only because I only care about what's underneath there. We're going to take that x value out, and x has to be greater than or equal to 0. This isn't very complicated, so I didn't have to solve for it. So this is your restricted domain. Now, one of the things I want you to start to look at is what does that look like in set notation. So remember, we're going to start at 0. 0 is part of our domain. So we're going to start at 0 and go infinitely to the right. So that's to positive infinity. Because 0 is part of our domain, it gets a bracket. Infinities always get a parentheses. So this is the same thing in set notation. So let's move back over here. Well, how do I write set notation for just x cannot equal 4? So x can be any number we want to, just not 4. So our domain goes from negative infinity to positive infinity. So we're going to start at negative infinity. Infinities always get a parentheses. We're going to go until we hit 4. Then we've got to leap over 4 because we can't include it. So because it's not included, the 4 gets a parentheses. Then you're going to union that with the next section. So we've got from 4 to positive infinity. We don't include 4, and infinities always have a bracket. So this and this are saying the same thing. So I always like to put something like what I just did on the number line. So if I look at the number line, and here's my boundary point of 4, and 4 is not included, but we go all the way to negative infinity to positive infinity. We're traveling along this number line. We go from negative infinity till we hit 4. We can't include 4, so half of our domain is from negative infinity to 4. Because 4 has an open circle above it, we have parentheses. Then we're going to union this side with this side, so we union them together. Then we're going to go from 4 to positive infinity. Again, because 4 has an open circle, we have a bracket there. And then the last thing that could restrict a domain would be a real-life problem. So real-life problems oftentimes require us to have a positive number, or 0 sometimes could be allowed as well. But if we're looking at like lengths of the side of a rectangular garden, well, lengths cannot be negative. So we're automatically restricted to the fact that in real life, a length is positive. There's no such thing as a negative length. Also, there are certain things that only come in integers, like a dollar bill. I mean, I realize you could have change, but if somebody says you only have paper dollar bills in your pocket, you're only going to have dollar bills, so you won't have any change. So just pay attention to your word problem. Oftentimes, just the nature of the problem itself is going to restrict the domain. All right, so what I want you to do is try to find the domains of each of the following using one of the 4 above. So pause the video, see if you can figure out what the domains are, and then restart the video and check your answers. All right, so when you are looking at a list of ordered pairs, you should be focused solely on the x values because that's your domain. So in this particular case, the domain is equal to, and we're just going to list out the x values, so we use those little curly braces, which I don't write very well, but there you have it. So I've got a 4, a 3, and a 6. And then in this next equation, I'm just looking at the expression, and because it's not in a fraction, it's not underneath a radical, and it's not a real-life problem, this is unrestricted. So your domain is equal to the set of all real numbers, which is negative infinity to infinity. This next one, the only part of this expression that restricts your domain is this denominator. So it is restricted. So x minus 8 cannot equal 0. So if you add 8, x cannot equal 8. So your domain is going to be, you can go from negative infinity, you're going to reach 8. We can't have 8, so we're going to put an open circle, which is a parentheses, union that with 8 to positive infinity. The next one, oops, get rid of that. For this next one, if I could select the right button, the 2x minus 2 is underneath the radical. This value, 2x minus 2, has to be greater than or equal to 0. So the 2x minus 2 is restricted to being equal to greater than or equal to 0. So I'm going to add 2 to both sides. So I get 2x is greater than or equal to 2. Divide both sides by 2. I get x is greater than or equal to 1. And so our domain would equal, we have to start at 1 and go to the right positively. So we're going to start at 1 and include 1. So we're going to go from 1 to positive infinity. We include 1, so it's actually a bracket, and then parentheses. And then finally, we have a real-life situation involving volume of a rectangular solid, a box. Length times width times height. Well, length, width, and height of a box has to be greater than or equal to 0. They cannot have a value of 0 or you don't have a solid. You just have a length and a width and no height. That doesn't make any sense. So for this one, it's a little different. Your domain would look like this. Length, comma, width, comma, height has to be greater than or equal, not equal to, we already explained why it couldn't be equal to, so it has to be greater than 0. All right, last page are some applications. So here we go. So as we look at example 5, it is a real world problem involving a cylinder. And so we're making a new soft drink can that is a little narrower and taller than the regular can. Here's some information that they give you that's really important. So if I were you, I would highlight it. We know that the ratio of the height to the radius is 4, and they also kindly gave you the volume of a cylinder. So as soon as I see the ratio of height to radius, so h over r is equal to 4, that's something that would be important to know. So notice that given, we have that part. And so that will always be true for this particular example. And then the first thing that they want to ask you is write the volume as a function of the radius. Well, what does that mean? Well, think of it. Let's highlight this. Write the volume as a function of the radius. So what they're saying is they want you to write it as f of r, function of the radius. F of r. So that means that r is your input. And your output is going to be the other variable, h. So I want it to be in terms of r because r is my input. So I want this equation right here to be something equals stuff in terms of r. So I'm going to solve it for h. So solve for h. Okay, so I'm going to just do it right over here, if you will. So if I'm solving for h, I'm looking at h, and I see that pi r squared is being multiplied to h. So to undo that, I'm going to divide this by pi r squared to both sides. And that actually solves it for h for me. So I end up with h equaling v over pi r squared. And then to write it as a function of the radius, it would look like f of r is equal to v over pi r squared. So this is the answer that they want. And notice that it's a function of the radius. So our input is r, and notice that the only variables between h and r are r. I mean, the volume's always going to be in both of these. The next one says, it's just the reverse, you're going to find the function of the height. So the function of the height means that we are going to be looking for f of h. So that means that h is my input. I want to solve for r. So I'm going to take that function, v equals pi r squared h, and I'm solving for my r right here. Oops. Let's write out that r squared over it. Okay, so r is having, well, r squared is having pi and h multiplied to it. So we're going to undo that by dividing by pi and h. So these go away. So I'm currently left with r squared is equal to v over pi times h. To solve for r, we're going to take the square root of both sides. Normally we would do a plus or a minus over here, but because v and h have to be positive values and r has to be a positive value, there's no way r can be negative, so we're ignoring the negative part of that. And we end up with r equaling the square root of v over pi h. Then to write it as a function, it would be f of r, f of h. F of h is equal to the square root of v over pi h. All right, then the final thing is going to be our difference quotient, and this is the part that's going to be a little bit difficult for you. So you might have to watch this part of the video several times and work several problems. All right, so when you do the difference quotient, you need to look at it as if you have three different pieces, this f of x plus h minus this f of x. So I'm really doing two substitutions. I'm taking this f function, and wherever I see an x plus h, I'm going to plug it in for this x here. Then I'm going to subtract the f function exactly as you see it, and then divide the whole thing by just an h, always in h. Our goal eventually, at the very end, will be to have no h here in the denominator. So sometimes the math gets horrendous. It seems to be horrendous and complicated, but the more work you write down, the less complicated it will end up being. I know it's going to look like a huge, ugly fraction, but just take every little piece at a time. You're better off more on paper, less in your head, kill that tree. All right, so let's start off with, I typically like to have you write this out so that you have this f of x plus h function minus this plain f function all divided by the h. So I'm going to start off by having these big brackets minus and all over h. So then this right here, this x plus h, I'm going to write the f function, but instead of the x, I'm going to use substitution parentheses only around the x itself, and then plug in that x plus h. So I've got negative 2, big parentheses, plus 4. So remember, this says substitute in for any x value into here, x plus h. So this is where the x value was, so I'm going to highlight that. So I'm plugging this x plus h right into here. So that went right there. Then the next part is you're going to subtract just the plain f function. See, you're just subtracting the plain f function. So I'm going to take the f function where I didn't do anything to it. I'm just leaving it plain. Negative 2x plus 4. These brackets are highly important because I'm subtracting the entire f function, not just the negative 2x. So this negative has to get distributed to everything inside of there, and essentially all the signs of the f function are going to change. If you forget these, I tend to have kids only changing the sign here and not here. So now all that's left is to do the math. So I'm going to distribute the negative 2 into here. So I get negative 2 times x is negative 2x, and then negative 2 times h is negative 2h. Bring down this plus 4, and then you're going to distribute this negative all the way through. So a negative times a negative 2x is a positive 2x, and then a negative times a 4 is a negative 4, and then it's all over h. Then once you clear all those parentheses and all you have left is to collect like terms, just start with one term and see, is there anything that will cancel with a negative 2x? Because there's lots of things up here that are going to cancel with each other. So notice that I have a negative 2x and a positive 2x. If I were you, I would actually show the canceling of those. Anything that stays, I would circle. So since there's no h term here to cancel with the negative 2h, I would circle that negative 2h, and of course the 4 and the negative 4 are also going to cancel. So all I have left in the numerator is a negative 2h, and in the denominator is an h. So now, because I just have a monomial divided by a monomial, the h's can cancel, and I'm left with a negative 2. So the difference quotient simplified, and this is always the difference quotient. This just happens to be the function that we're going to use in this difference quotient. So f of x plus h minus f of x all divided by h simplified to negative 2. All right, so let's look at a more difficult example. So this time our f function has changed. This time we have two places where there's an x, and in fact we have an x squared, which is going to create a bit of an issue. We still have the same difference quotient. So I'm still going to substitute in for the first substitution in x plus 8. I'm still going to approach it or start it the same way I did the last one. Oops, that is not what I meant to have. Seem to be doing that a lot lately. All right, so I'm going to start with one big bracket minus another big bracket. In fact, I might make this bracket a little longer, like maybe over here. So this first bracket is for f of x plus h is going to go in here. Then minus f of x is going to go in here, and then all over, don't forget that, the h. Okay? So right here I have two x's, so my substitution parentheses are going to go here and here. So in my first set of brackets, I'm going to put big substitution parentheses squared minus 4 big parentheses plus 7. So all I have here is the x squared minus 4x plus 7, x squared minus 4x plus 7. So inside here is going to go my substitution, which is the x plus h is going to go here and here. So x plus h. We'll do that math in a minute. So right now this is a substitution of the f function where I substituted in x plus h. Then for the second part here, you're just going to bring down the f function exactly as you see it. So x squared minus 4x plus 7. Now do the math. So I'm going to start with, remember that this is not x squared plus h squared. You actually have to take x plus h and square it. So I'm going to take x plus h times x plus h, and then I am going to go and distribute the negative 4 all the way through. So negative 4 times x is negative 4x. Negative 4 times h is negative 4h plus that 7. Then we're going to distribute this negative all the way through, which changes all the signs. So instead of an x squared, I have a minus x squared. Instead of a minus 4x, I have a plus 4x. Instead of a positive 7, I have a negative 7, all over h. Don't start canceling anything yet because we still have parentheses here. So I am going to double distribute this. I'm going to have the x times everything there, and then the h is going to get multiplied to everything there. So I'm going to have 4 terms. So x times x is x squared. X times h is positive xh. H times x is positive xh again. And h times h is positive h squared. Then minus the 4x, minus the 4h, plus 7, minus x squared, plus 4x minus 7, all over h. Now I know some of you are like, oh, forget it. Don't let that bother you. I didn't do anything here previous to what I did up here. I just brought it down. This is something that you're perfectly capable of doing. It's all right here. And I just brought everything down. It just looks complicated. It's really not. So start with your highest degree term, the x squared. Is there anything here that will cancel with a positive x squared? Oop, there's something. So I'm going to cancel the x squared with a negative x squared. Then this xh and this xh, I don't see any other xh's, are going to combine. So I'm going to highlight these. So I've got an xh and an xh. So they are going to give me 1 xh plus 1 xh is going to give me 2 xh's. Okay, so then this is an h squared. I don't see a negative h squared here anywhere. So I'm going to circle that and bring it down. So plus h squared. The purpose of circling it is so that you don't lose it. Then I have a minus 4x and a positive 4x. So I am going to cancel the minus 4x and the positive 4x. Next we have a minus 4h. There is no other 4h, so I'm going to circle this and bring down a minus 4h. Finally, we have a positive 7 and a negative 7, and those are the only things that are left, and fortunately they cancel. So then don't forget that this is all over h. Remember, the whole point is that we're trying to get rid of this h. If you don't get rid of this h, you did something wrong. Notice that each of these terms has an h in common that I can factor out as a greatest common factor. So I'm going to factor an h out in front, all over h. So if I divide each of these by h, divide by h, divide by h, we're going to write what we have left. So here the h's cancel, and we're left with a 2x. Here, this h cancels with one of those, so I'm left with an h, so a positive h, positive h. And then here the h's cancel, and you have a minus 4. So now that you factor this h out in front, it can finally cancel with the h in the denominator. So this h cancels with that h. And for your final answer, you have 2x plus h minus 4. It does not matter what order those are in. Congratulations, that is about as difficult of a problem as I will give you. So please try the 3 problems I gave you for homework, and let me know where you get stuck. Have a good night.